In this video, we're going to be solving for the power density of an isotropic antenna. And anytime I do an equation like this, the first thing I do is write out the formula and then list the givens. Let's write out the formula here. Power density of an ISO is equal to PT over 4 pi range squared. The givens for this formula are range is equal to 230 kilometers, a pulse width, 25 microseconds, a PRF of 280 hertz, and lastly, a peak power equal to 43 kW. Now that we've got the formula and the variables, we can start pulling apart the equation. First thing that we're going to look at is the top part. And PT is power total, which in our case is equal to power average. For this, we can kind of refer to our formula sheet. And right here, we see that power average is equal to the peak power times the duty cycle. Let's go ahead and write that down. We already have the peak power, 43 kW. That leaves us to solve for the duty cycle. Let's refer back to our formula sheet. And if we're looking for duty cycle, we've got three options. We have average power divided by peak power, pulse width times PRF, and pulse width times PRT. So we can match this up to the variables that we're given. We see that pulse width times PRF is going to be our best option. So this second one here on the equation sheet. And to find duty cycle, pulse width times PRF, or 25 microseconds, times 280 hertz. You're going to do this with me on your calculators. I'll go ahead and type this in. 25 e to the negative 6 times 280 hertz. We get the answer in engineering notation, and as you guys know by now, the duty cycle's in decimal. So I have 43 kW times 0.007. Real easy, I can just finish this out in the calculator, times 43 e to the third. We get 301. So the top part of the equation is done. The power average for us is 301 watts. Let's move on to the bottom part. We get 4 pi range squared. We know our range is 230 kilometers, so here in a second we'll enter this into our calculator, and you can do it just like this, parentheses 230 k squared. And let's see what that gets us here on the calculator. 4 times pi times 230 k, and let me go back here, I'll put the parentheses in, 230 k, and we'll just use the square button there. So you get 6.64 times 10 to the 11th. And what I'm going to do with that number is I'm just going to save it in the memory, and then I'll clear out my calculator. So all that's left at this point is to divide 301 by the number we just got. So I'll type in 301 divided by, we'll recall this number, and we get our answer here. Let me switch it back over into engineering. What we come up with is 452.79 picowatts. And this is good, but our answer is not complete yet. If we remember, anytime there's a power density involved, we're talking about power over area. So we need to finish this equation off with a unit measure of meters squared. And this is our answer.